गुड मॉर्निंग स्टूडेंट्स, वेलकम टू बिंदु धडवाल केमिस्ट्री लेसन्स। आज हम सॉलिड स्टेट के कुछ इम्पॉर्टेंट क्वेश्चंस की बात करेंगे जो कि बोर्ड के फर्स्ट टर्म के एग्ज़ाम में आ सकते हैं। तो फर्स्ट कैटेगरी जहाँ से क्वेश्चंस पूछे जाएंगे है वो मल्टीपल चॉइस क्वेश्चंस, उनकी हम प्रैक्टिस करेंगे। कुछ इम्पॉर्टेंट डेफिनेशंस हैं जो आपको आनी चाहिए, जिनमें से 1 और 2 मार्क्स के क्वेश्चंस पूछे जा सकते हैं। फिर कुछ डिफरेंसेस क्वेश्चंस हैं जो बहुत बार पूछे गए हैं और अभी भी पूछे जा सकते हैं, उनके बारे में हम बात करेंगे। प्लस नेक्स्ट इम्पॉर्टेंट टॉपिक जो है इस चैप्टर में से किस तरह के न्यूमेरिकल्स पूछे जाते हैं बोर्ड के एग्जाम्स में। तो लेट अस स्टार्ट विद द मल्टीपल चॉइस क्वेश्चंस। So first question is, iodine molecules are held in crystal lattice by, because it's a molecular solid, तो molecular solid में जो force of attraction है London forces या dispersion forces. So option A is the correct answer. Which of the following is a network solid? So sulfur dioxide, iodine and water are molecular solids, whereas diamond is a 3-dimensional network solid. So option C is the correct answer. The lattice site in a pure crystal cannot be occupied by electron. Option C is the correct answer, क्योंकि pure crystal में कोई डिफेक्ट नहीं होता है। अगर डिफेक्ट आए तब एनाइन के साइट, मिसिंग एनाइन के साइट पर इलेक्ट्रॉन आता है, क्योंकि प्योर क्रिस्टल है तो वहाँ इलेक्ट्रॉन नहीं हो सकता है। ऑप्शन सी इज द करेक्ट आंसर। Which of the following oxides behave as conductors or insulators depending upon temperature? तो टाइटेनियम ट्राईऑक्साइड TiO3 जो है ये लो टेम्परेचर पे इंसुलेटर और हीट करने पर हायर टेम्परेचर पे कंडक्टर की तरह बिहेव करता है, ये ट्रांजिशन शो करता है। वेरएज मैग्नीशियम ऑक्साइड आयनिक सॉलिड है, क्रोमियम डाइऑक्साइड जो है ये एक मेटालिक सॉलिड की तरह बिहेव करता है, और SiO2 इंसुलेटर अकेले की तरह बिहेव करता है। Cations are present in the interstitial site in Frenkel defect. Option A is the correct answer. To get a N-type semiconductor from silicon, it should be doped with a substance with a valency 5. N-type semiconductor में conduction of current is because of N means negatively charged electrons. तो अगर टेट्रावेलेंट सिलिकॉन में एक पेंटावेलेंट इम्प्योरिटी हम डालेंगे तो एक्स्ट्रा इलेक्ट्रॉन मूव करेगा और कंडक्टिविटी के लिए रिस्पॉन्सिबल होगा। इसलिए एन टाइप सेमीकंडक्टर्स में जो इम्प्योरिटी होती है वो पेंटावेलेंट, उसकी वैलेंसी 5 होती है। ऑप्शन डी इज द करेक्ट आंसर। अ सब्सटेंस AXBY crystallizes in a face-centered cubic lattice in which atoms A occupy each corner of the cube. अब क्योंकि एक क्यूब में 8 कॉर्नर्स होते हैं और हर एक की कॉन्ट्रीब्यूशन 1/8 होती है, तो नंबर ऑफ एटम्स A विल बी 8 into 1/8 is 1, और B एटम ऑक्यूपाइज द सेंटर ऑफ ईच फेस। तो एक फेस जो है वो 2 यूनिट सेल्स शेयर करते हैं और 6 फेसेस होते हैं, तो दैट मीन्स कि B के 6 एटम्स हर एक की कॉन्ट्रीब्यूशन 1/2, तो दिस कम्स आउट टू बी 3. So A1B3, option A is the correct answer. Which of the following shows ferromagnetism? So option B, CrO2 is the correct answer. Titanium dioxide is diamagnetic, MnO is antiferromagnetic, Fe3O4 is ferrimagnetic. So option B shows ferromagnetism. A solid has a structure in which tungsten atoms are located at the corners of the cube. So corners में है तो means 8 into 1/8 tungsten atom होगा 1. Oxygen atoms at the center of edges. There are 12 edges और हर edge की contribution 1/4 होती है, तो 12 into 1/4 means 3. So oxygen will be 3, and sodium atom at the center of the cube, that means there is only one sodium atom. So the formula will be NaWO3. So option B is the correct answer. For octahedral coordination, the radius ratio should be between 0.414 to 0.732. Option C is the correct answer. The number of atoms in body-centered cubic arrangement per unit cell will be 2, because 8 atoms are present at the corner, so 8 into 1 by 8 is 1, and 1 in the center, so that's contribution is whole sum. The total answer becomes 1 plus 1, 2. So option B is the correct answer. If the alignment of magnetic moments in a substance in a compensatory way so as to give zero net magnetic moment, then the substance is said to know as antiferromagnetism. The number of atoms present in FCC unit cell is 4. Atoms are present at the corners as well as in the center of the 6 faces. So corners is 8 into 1 by 8. That means 1. And there are 6 faces. The contribution of each face is 1 by 2. So this comes out to be 3. So 3 plus 1, 4. So option C is the correct answer. Volume occupied by atoms in a simple cubic crystal is 52.4%. Volume occupied by atoms in face-centered cubic is 74%. Option A. Volume occupied by atoms in BCC is 68%. What is the radius ratio for coordination number 8? It is between 0.732 to 1. Close packing is maximum in the crystal, which is of the 4 options. Close packing is maximum in FCC, 74%. In solid lattice, the cation has left a lattice site and is located at an interstitial position. The lattice defect is Frenkel defect. Option C is the correct answer. The coordination number of a metal crystallizing in a hexagonal close packing structure is 12. So option A is the correct answer. The coordination number in case of cubic close packing CCP is 12. When unpaired electron is trapped in anion vacancy, then crystal with such a defect is said to have F center. The amorphous solid among the following is plastic. The empty space within HCP arrangement is 26%, 100 minus 74%. Which of the following is a molecular solid? So ice is a hydrogen bonded molecular solid, rock salt is ionic solid, diamond is network solid, and quartz is a crystalline solid. The space occupied by sphere in BCC arrangement is 68%. The appearance of color in solid alkali metal halide is generally due to F center. The number of tetrahedral voids per atom is 2 in a crystal lattice. Which of the following is an amorphous solid? Glass is an amorphous solid. In body-centered unit cell, the number of atoms present are 2. In face-centered unit cell, the number of atoms are 4. Which of the following is an insulator? Diamond is an insulator. With increase in temperature, the conductivity of semiconductor increases. Option B is the correct answer. So next important definitions that you should learn, which can come in the exam, are anisotropy. So in a crystalline solid, some of the physical properties such as electrical resistance or refractive index show different values in different directions. Such properties in crystalline solids which show different values in different directions is called anisotropy, and the substances are called anisotropic substances. Isotropy is the property possessed by amorphous solids in which these physical properties such as electrical resistance or refractive index are same in different directions. Then the property is called isotropy. Crystal lattice. The regular three-dimensional arrangement of atoms is called crystal lattice. Unit cell. The smallest portion of a crystal lattice which, when repeated again and again in different directions, generates the entire crystal lattice is called unit cell. The coordination number of a particle in a crystal lattice is the number of immediate neighbors of that particle in the crystal. So for radius ratio, the ratio of the radius of an atom which is present in the void to that of the atom which forms the crystal lattice, this ratio is called radius ratio. For a tetrahedral void, the radius ratio is 0.225. Whereas for an octahedral void, this radius ratio is 0.414. Doping. The process of adding an impurity to a germanium or silicon crystal so as to increase its conductivity is called doping. For example, when a pentavalent impurity is added to silicon or germanium, it forms an N-type conductor. Similarly, when a trivalent impurity is added to silicon or germanium, a P-type semiconductor is formed. This process of adding impurities is called doping. Interstitials. When an atom leaves its original state to occupy the interstitial site between the other atoms in that crystal, then the product formed is called interstitial. F centers. When an anion leaves its site in a crystal and an electron occupies the vacant site, then it is responsible for color of that crystal, and this electron occupying the anion vacancy is called F center. Paramagnetic substances. substances that are weakly attracted by magnet are called paramagnetic substances. These are due to presence of unpaired electrons in the crystal. And when a substance is strongly attracted by magnet, then the substance is called ferromagnetic substance. It is because of presence of large number of unpaired electrons in the crystal. When a substance is supposed to be ferromagnetic, but it is not strongly attracted, it is only weakly attracted by substance because the unpaired electrons cancel each other spin or magnetic moments so as to result in a net small amount of magnetic moment, then such a substance is called ferrimagnetic substance. On the other hand, if the substance is supposed to be ferromagnetic, but its magnetic moments in different directions are exactly cancelled by each other so that there is no net or zero net magnetic moment, then that substance is called anti-ferromagnetic substance. So, ferromagnetic substance can be strongly ferromagnetic when all the magnetic moments point in one direction, anti-ferro when they point in different direction and exactly cancel each other, and ferrimagnetic when they cancel each other but there is a small net magnetic moment, then it is called ferrimagnetic substance. So these are some important definitions which may be asked in the examination. Learn them. 1 or 2 questions will come from these definitions. Next important trend, a question that is being asked is difference between crystalline solids and amorphous solids, difference between hexagonal close packing and cubic close packing, between a tetrahedral void and octahedral void, then Schottky defect and Frenkel defect, N-type and P-type semiconductors, and how to explain the difference between a conductor and an insulator in terms of band theory and conductor and a semiconductor in terms of band theory. These are some important questions that are asked. The numericals that are commonly asked from the solid state can be categorized into 4 categories. First is to calculate the number of atoms present in simple cubic, face-centered cubic, it is also called cubic close packing, CCP, and body-centered cubic units. So number of atoms, as we have done in the objective type, in simple cubic is 1 per unit cell, in FCC it is 4 per unit cell, in BCC it is 2 per unit cell. Then second type of numericals that are commonly asked is to find formula of a compound. They give the location of different atoms, say A and B, present in different parts of the lattice, and they ask you to find the formula. The third category is relationship between nearest neighbor distance and D and edge length or radius and edge length of a unit cell. And the fourth category is they will ask numericals based on density, edge length, and molar mass. They may either ask you to find the density of a lattice giving other parameters of the solid state, or they may ask you to find the number of atoms per unit cell Z, or the molecular mass or atomic mass of the substance. So practice numericals of this type. How to solve these numericals and the differences between these properties we will cover in the next video. So subscribe to my channel, keep following my videos, and let us practice for the exams in the first term in the year 2022-23. That's all in today's video. Thank you. Have a nice day.